Hello there, and welcome back to the Science Sleepy Minds. Tonight, you're standing alone on a planet that doesn't quite feel like Earth yet. The sky is a swirling haze of volcanic ash and steam. The oceans are boiling in places, and the ground beneath your bare feet is still crusting over from the chaos of planetary formation. There's no grass, no birdsong, no comforting blue above, just a brooding sky and the strange scent of minerals baking in the heat. The air is thick, probably not breathable, but you're here anyway because we're telling a story. And at the center of that story is the moon. Not the gentle white lantern you're used to seeing from your bedroom window, but something new, raw, and impossibly close. It hangs in the sky like a molten scar, still glowing faintly from its violent birth. It's huge, about 15 times larger in the sky than it looks today. You probably won't survive this, by the way. Between the atmospheric toxicity, the magma rivers, and the frequent asteroid showers, it's not exactly prime real estate yet. But that moon, it's going to change everything. So, before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here. And hey, I'd love to know where you're watching from and what time it is where you are. Drop it in the comments below. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You step slowly across a desolate plain. The air is heavy with carbon dioxide and methane. A thunderstorm rumbles in the distance, though there's no rain, just electrical tantrums cracking across a copper-colored sky. And then through the haze, you see it rising. The moon. Not silver, not serene, but something else entirely. It's still forming. A churning ball of molten rock, born from fire and violence, and far closer than it should be. Its gravity is already tugging at Earth's surface, creating primitive tides in the magma oceans. That's right, magma tides. Welcome to 4.5 billion years ago. You blink and now you're watching it all happen in slow motion. Not poetic slow motion, but literal geologic time. You see a rogue planetary body, nicknamed Theia, about the size of Mars, veer slightly off its trajectory. It doesn't miss. It slams into Earth at an oblique angle, and the impact is, well, let's call it a little dramatic. Molten rock sprays out in arcs that rival Saturn's rings. A significant chunk of Earth's crust and Theia's remains are blasted into orbit. And over the next few million years, a blink in cosmic time, those fragments coalesce. They spiral inward, compact, heat up, and become the moon. It doesn't take long for this chaotic debris disk to become a single body. But it's not serene. Not yet. The moon is still molten. Its surface convulses with impacts. Every crater is a birthmark from its violent youth. Historians still argue whether Theia contributed any water to Earth or stole some on her way out. Some believe Theia brought in key elements that helped make Earth habitable. Others argue she took a chunk of Earth's early atmosphere and sent it packing into space. Either way, the result is the same. The moon is a part of Earth, literally, a recycled sibling, and somehow that cosmic sibling will end up being your planet's most loyal partner. Now here's your first quirky tidbit of the night. For a long time, some scientists flirted with the idea that the moon was captured, that it formed elsewhere in the solar system and got caught by Earth's gravity, sort of like a space stray. But that theory's gone out of fashion. The chemistry just doesn't add up. Lunar rocks, yes, we've brought some home, are eerily similar to Earth's upper mantle, like puzzle pieces from the same original body. So the moon wasn't adopted. It was born from trauma. Like the world's first overdramatic origin story. And that drama, it wasn't just for show. Without that impact, Earth would be a very different place. Maybe not lifeless, but definitely lonely. The moon's existence shaped our atmosphere, our tides, our seasons, and even the length of our days. And tonight, we'll trace all of that. But for now, just stand under that enormous molten globe and feel the future unfolding. Because this glowing sphere hanging above you, this ancient wound turned guardian, is about to begin its lifelong job, making Earth not just a planet but a home. Down at your feet, early Earth is trying to cool. The crust is forming, though it still heaves and cracks like a skin too thin for what's beneath. Volcanoes pop off like bubble wrap. And the moon, it's stabilizing. Its own crust is hardening. It's pulling away ever so slightly, about 3.8 centimeters a year. But for now, it's still close enough to cast twin shadows when the lava fountains erupt. Honestly, it's kind of beautiful, if terrifying. You can almost hear it humming. Not literally, there's no sound in space, but the moon has a seismic signature. Even today, its internal moonquakes are gentle echoes of a still cooling heart. Back then, it probably throbbed with thermal energy. Scientists believe it had a molten core for a time. It may have even had a magnetic field in its youth, though that too is debated. Lunar mysteries still linger in our telescopes and our textbooks. So you take a few more steps across that newborn landscape. The moon above is less a light in the sky and more a constant, quiet promise. From now on, Earth is no longer alone. And though the air is toxic and the oceans are just beginning to calm, the stage is set. The chemistry of life is stirring in warm little puddles. The moon is tugging at Earth's crust, and somewhere in the shadows of its glow, the first building blocks of biology are waiting to form. You don't even hear it coming. The impact is silent in the vacuum of space, but in your imagination, it thunders. A planet-sized scream muffled only by distance. Theia, our rogue interloper, crashes into the still-forming Earth with all the subtlety of a cosmic punch. You float just far enough above the surface to watch it unfold in planetary slow motion. It isn't a clean hit. It's a glancing blow, a perfect angle to shear off part of Earth's outer layers while sending Theia to its doom. Molten rock, vaporized crust, and metal eject into orbit, an incandescent halo of planetary shrapnel. It looks like chaos, but it's the origin of something orderly: the moon. Scientists call it the giant impact hypothesis, and yes, it's the leading theory on how we ended up with our moon. It replaced earlier ideas, like the moon forming alongside Earth from the same primordial disk, or being captured like some galactic hitchhiker. But those theories couldn't explain why Earth and moon rocks are chemically similar, like siblings, not strangers, and definitely not twins. The moon is oddly light on iron, which supports the idea that it formed mostly from Earth's crust and upper mantle after the impact, rather than its denser core. The debris from this apocalyptic collision doesn't just float around forever. It begins to swirl, drawn together by gravity and locked into Earth's orbit like a reluctant satellite. Over the next few million years, barely a blip on the cosmic clock, that molten mess condenses into a single searing sphere. The moon is born not as a white, glowing beacon, but as a hellish orb, pulsing with leftover heat from the collision. And for a brief time, the moon might have had its own atmosphere, a thin, vaporous layer made of sodium, silicon monoxide, and gas from the impact itself. It was short-lived, probably lasting just a few million years. But imagine that, a baby moon with a warm exhale. Here's something weird for your sleepy brain to chew on. At one point in those early days, the moon was just 22,000 kilometers away. That's about 1/6 the distance it is now. It filled the sky, so enormous that it might have looked 15 to 20 times bigger than the moon does today. Nighttime wasn't just illuminated, it was dominated. No wonder our ancestors were obsessed with it. It was practically a ceiling decoration. Historians still argue whether that early moon was ever truly synchronous, whether it always showed us the same face right from the start. What we do know is that today, it's tidally locked. One face always gazes down, its features familiar to every human who's ever looked up and whispered a wish or a curse or a question. But back then, the moon rotated faster. It may have wobbled and spun in fits. Eventually, though, it slowed, dragged into synchrony by Earth's gravity. That tug-of-war between rotation and orbit gradually settled into what we now call tidal locking. You can picture it, can't you? The two celestial bodies, still fresh from their shared trauma, locked in a gravitational dance. Earth spins rapidly, days flying by in just 6 hours. Meanwhile, the moon circles in closer orbits, stirring Earth's molten oceans, raising tides not of water but of rock. Oh, and here's your quirky science tidbit of the night: those magma tides. They may have helped Earth's early magnetic field stabilize. The internal churning could have helped keep Earth's liquid core moving, generating a protective magnetosphere, the invisible force field that shields us from solar radiation. No big deal. Just the moon casually helping us not get microwaved by space. Now you're drifting alongside the moon as it gradually cools. Its surface hardens into basaltic plains, those dark blotches you can still see with the naked eye. They're called Maria, which means seas, though they're bone dry. Iron-rich lava seeped across its crust, spreading out like cosmic icing. And even as the surface settled, comets and asteroids bombarded both Earth and Moon for hundreds of millions of years, a period known as the Late Heavy Bombardment. You watch as one such rock slams into the Moon's southern pole, carving out the Aitken Basin, one of the largest impact craters in the solar system. Meanwhile, Earth's atmosphere, thickening from volcanic gases and comet-delivered water, shields the planet from similar impacts. But the Moon, it becomes a cratered diary of the solar system's most violent era. Like an old boxer, it carries every punch on its face. But this violent start has long-lasting benefits. For Earth, the debris ring formed by Theia's impact may have helped strip away excess carbon dioxide from the atmosphere, a natural climate regulator in the making. The Moon, born from that ring, would become Earth's partner in planetary balance. There's a gentleness forming now. As the Moon pulls away centimeter by centimeter, Earth's days begin to stretch. No longer are there just 6 frantic hours of sunlight. The spin slows, the tides evolve, and the planet begins to hum at a steadier rhythm. The Moon, cooling rapidly without any atmospheric insulation, becomes a quiet reflector of sunlight, no longer molten, but glowing with borrowed light. At this point, something subtle yet profound is happening. Earth is becoming livable. It's not ready yet. No meadows, no rivers, no Instagram sunsets. But the stage is being set. The Moon, once a chaotic ball of debris, is now a steady, gravitational anchor. And it's only just begun to shape life. You stand barefoot at the edge of a tide pool. Not just any tide pool, but one bubbling on the ancient shoreline of Earth, somewhere around 4 billion years ago. It's not the kind of serene seaside scene you might picture on a postcard. The air smells sharp, like minerals and metal. The water is warm, not because it's summer, but because the Earth is still bleeding heat from within. And the Moon, it's there above you, impossibly huge, dragging the oceans back and forth like a child swinging on a curtain. Each time it pulls, the sea heaves up the beach, and each time it releases, the water rolls back, leaving behind shallow puddles that steam in the sunlight. Inside these pools, chemicals swirl, amino acids, fatty molecules, and bits of carbon chains. They clump, split, rearrange. None of them are alive yet. But here's the real kicker. They wouldn't even be here without the Moon. That rhythmic push and pull, the tidal flexing, keeps stirring the primordial soup. It's not just about sloshing water around. The repeated wetting and drying of these pools creates the perfect conditions for complex molecules to link together. No Moon, no tides. No tides, no chemical concentration. No concentrated chemistry, no, well, you. Scientists love to talk about the Goldilocks conditions for life: liquid water, stable temperatures, energy sources. But one of the more underrated ingredients: time. Not time as in billions of years, though yes, that too, but rhythmic time. The kind of daily, repeatable cycles that give molecules a schedule, a beat to dance to. Historians still argue whether life began in these coastal tide pools or at the scalding mouths of underwater hydrothermal vents. Both environments have strong cases, but the moon tide theory has a poetic logic. Life began not in stillness, but in motion. And here's your quirky tidbit. If Earth had no moon, our tides would be a fraction of what they are now, caused only by the sun and very weak. Barely a ripple. With the moon, though, early tides may have surged hundreds of miles inland. Some estimates say they were so extreme that entire coastlines vanished and reappeared every few hours. Imagine an ocean trying to punch its way onto land and succeeding. You walk a little farther along this jagged shoreline, watching as new pools are formed, some foaming with strange compounds. The moon continues to pace above, utterly relentless. Its orbit isn't just tugging water, it's also tugging the planet's crust. The land itself subtly flexes beneath your feet. You can't feel it, but the Earth knows. That gravitational massage may have helped keep Earth's interior dynamic, pushing plate tectonics into gear. Because guess what? Life needs land too, not just as a place to exist, but as part of the planetary recycling system. Volcanoes bring up nutrients. Tectonic subduction buries carbon. The moon, indirectly, keeps the whole thing spinning. As you crouch by a particularly promising little pool, something glistens. Not alive, not yet, but complex. A bubble of lipids has formed, encasing water. A protocell. A whisper of life. It's fragile, just a tiny droplet surrounded by a greasy film. But these are the first hints of what's coming. It's funny to think how random it all seems. You need the right atmosphere, the right temperature, the right pressure. And yet, one of the biggest contributors, the moon, an accidental satellite formed from a catastrophic collision, now patiently tugging on Earth's oceans so these early experiments in biochemistry can happen on repeat. Meanwhile, the tides also start to carve out estuaries, those in-between spaces where salt water meets fresh water. Rich, muddy habitats perfect for evolutionary play. It's in places like this that life eventually crawls out of the water for the first time. But that's getting ahead of ourselves. Right now, you're still watching molecules bump into each other like shy partygoers at a middle school dance. Some of them form chains, others break apart. But every cycle leaves behind a few more stable configurations. The pools evaporate, rain refills them, and the moon, tireless, keeps everything moving. And speaking of movement, let's talk about energy. Life doesn't just need structure, it needs fuel. And one of the biggest early sources, ultraviolet light, harsh, unfiltered, and unrelenting. Before Earth had an ozone layer, the sun's radiation blasted the surface like a sterilizing floodlight. It sounds bad, and it kind of was, but it also sparked chemical reactions that wouldn't have happened otherwise. The moon, in contrast, offered a reprieve. At night, it cooled the earth. It dimmed the chaos. It gave early molecules a break. That dark half of the day, illuminated only by the full moon's soft reflection, may have given complex structures a chance to settle, to form membranes, to start making copies of themselves. Every night the moon rose. Every night the pools cooled. And every night the dance began again. Here's a fun historical note. The ancient Greeks suspected the moon influenced the tides, but they weren't totally sure how. It took Sir Isaac Newton, yes, the apple guy, to formally explain the gravitational mechanics in the late 1600s. Up until then, the moon was mostly blamed for madness, werewolves, and women's moods. You know, the usual. But long before Newton, long before even people, the moon was already quietly pulling the strings of life's earliest beginnings. You step back from the tide pool now. Behind you, the land is still mostly barren. Before you, the sea stretches out into a horizon of possibility. And above it all, the moon glows like a lighthouse for molecules. Life hasn't started yet, not fully, but it's coming. And the moon, by simply being there, makes it all possible. You lie back on a warm rock, watching the earth spin. It's faster than you'd expect. The sun zips across the sky like it's late for something, and night rushes in with barely enough time to notice. A single day on early Earth is only 6 hours long. Blink too slowly and you'll miss a sunrise. The winds are fierce. The clouds spin in dizzying patterns, and the moon, ah yes, the moon, is looming large, like a watchful guardian barely keeping things in line. But don't worry, it's working on it. The moon is slowing things down, literally. Every time it pulls on Earth's oceans, it creates friction, gravitational resistance that gradually drags Earth's spin to a crawl. The tides roll in, get yanked ever so slightly out of sync with the planet's rotation, and in doing so, they act like a cosmic brake. Earth, once twirling like a kid on a sugar high, is being gently told to calm down. This slowing effect is called tidal braking, and it's a big deal. Without it, the planet would be spinning too fast for comfort. Think, hurricane-force winds every day, 1,000 km/h jet streams, and a chaotic climate where nothing gets a chance to settle. Not ideal for a picnic, or, life. So as you lie there in the shadow of the moon, you start to feel the rhythm of things. The lengthening days, the steady beat of tides, a planet easing into a more livable tempo. You wouldn't notice it over a single lifetime. This deceleration is subtle, about 1.8 milliseconds per century. But give it a few billion years. You go from 6-hour days to the nice, lazy 24 we know and love today. And here's your historical gem. Back in the 1800s, a Scottish geologist named James Kroll proposed that the moon's effect on Earth's rotation could influence climate over long periods. People thought he was eccentric. To be fair, he also believed in a hollow Earth. But today, he's considered one of the early pioneers of what we now call Milankovitch cycles, long-term variations in Earth's orbit and tilt that drive ice ages. And yes, the moon has a hand in that too. It's kind of a cosmic multitasker. Still, historians do argue whether early Earth had such neat cycles. Some suggest the climate was wildly unstable, with violent shifts in temperature and chaotic weather patterns. Others think the moon's steadying pull helped moderate things earlier than we realize. As usual, the truth probably sits somewhere in between, sipping lunar tea and refusing to comment. Back on your rock, you can feel the difference even now. With every passing million years, the day gets longer. The sun rises a little more slowly. The nights last long enough for cooling, for dreams, for photosynthesis to one day develop a circadian rhythm. Here's your quirky fact of the evening: coral fossils. Yes, corals, the little ocean architects, have growth rings that reveal the number of days in a year millions of years ago. Ancient corals show around 400 days in a year, which means shorter days and faster spins. They're like the planet's own wristwatch, ticking out Earth's rotational history in tiny, wavy lines. You close your eyes and imagine that spinning Earth ticking slower and slower as the moon retreats. Because yes, it's moving away. Not fast, just 3.8 centimeters a year. But over time, it adds up. The moon used to be close enough to create tides like tsunamis. Now it's more distant, more refined, like someone who's mellowed out after a chaotic youth. And that distance affects the tides, the rotation, even the balance of day and night. Earth's rotation loses a tiny bit of energy which is transferred to the moon, nudging it farther out in its orbit. It's kind of like a merry-go-round. You slow it down, and whatever's holding on flings outward. Some scientists believe that without the moon slowing us down, Earth might still be spinning rapidly, and life might have taken a very different path. Fast spins could prevent complex life from forming, or at least make it weirder. Imagine evolution under a 6-hour daylight cycle. Plants wouldn't have time to photosynthesize properly. No long afternoons for predators to hunt. No sleepy sunsets. Just a quick flash of dawn, a sprint through the day, and then back to darkness. Honestly, even your internal clock would be a wreck. Speaking of clocks, did you know that even today, our timekeeping systems have to account for Earth's rotational slowdown? Every few years, a leap second is added to keep atomic clocks in sync with the actual length of a day. Time, as it turns out, is a little wobbly, and it's the moon's fault. Now you sit up, noticing how the moon's path across the sky changes slightly night by night. It rises later each evening, About 50 minutes later, actually, because it's orbiting in the same direction Earth is spinning. This lunar lag becomes part of the daily rhythm, a quiet reminder that the moon doesn't just hover, it drifts. And what a drift it's been. From a superheated clump of debris to a gravitational metronome, the moon has done more than just slow Earth's spin. It's created consistency, predictability, the foundations for time as we understand it. You look up at that pale shape in the sky and realize it's not just a rock, it's a regulator, a timekeeper, a babysitter with gravitational authority. We tend to think of time as constant, as cold, as mathematical. But in this moment, lying on a prehistoric Earth under a growing moon, you can feel time as something warmer, a gift, a stretch, a breath. And without the moon pulling on Earth's oceans and tugging at its rotation, that breath might never have slowed long enough for life to begin. So as the night deepens and the moon continues its ancient packing, you stretch out on the ground, knowing that the whole planet is slowly settling into a rhythm. A longer day, a softer night, a better chance for life to unfold, not in chaos but in cycles. You sway a little on your feet, not from dizziness, but from the gentle, rhythmic rocking of the entire planet. Subtle, yes, invisible to the eye, but the Earth even now isn't as steady as you might think. It wobbles, tilts, leans and shifts like a drowsy dancer trying to stay upright after one too many gravitational nudges. And guess who's holding her hand through that whole clumsy routine? That's right, your old friend the moon. Tonight, you're not standing at the shoreline or floating in space. You're perched delicately on Earth's axis itself, feeling the angle of the planet beneath you. That familiar 23.5-degree tilt. It hasn't always been that way, and without the moon, it might not be that way at all. Because Earth, left to its own devices, is a bit of a wobbly diva. Let's zoom out. Earth's tilt, its axial obliquity, is what gives us seasons. When the northern hemisphere leans toward the sun, it's summer up there and winter down below, and vice versa. This tilt is essential. Without it, you wouldn't have shifting climates, plant growth cycles, animal migrations, or the bizarre human obsession with pumpkin spice in October. But here's the thing. Planetary tilts don't always stay stable. Mars, for instance, is a cautionary tale. Without a big stabilizing moon, its tilt swings wildly over millions of years, from nearly upright to a dizzying 60 degrees. Imagine the Sahara becoming a rainforest, then a glacier, then a rainforest again, all because the planet can't make up its mind. Earth could have suffered the same fate. Historians still argue whether our early tilt was more extreme or more gentle, but what's clear is this: the moon helped lock it in place. It acts like a gyroscopic anchor, dampening the chaotic influence of Jupiter's gravity and the uneven mass distribution inside our planet. You've probably never thought of the moon as a climate-controlled device, but here you are, basking in a relatively stable climate cycle, because a chunk of molten Earth got yeeted into orbit 4.5 billion years ago. And for your quirky science nugget of the night, the moon's stabilizing effect works best when it's close. So back when the moon was just 20,000 kilometers out, it was like a giant celestial hand holding Earth's head still and saying, "Nope, none of that wild tilting nonsense today, thank you." Over time, even as the moon has moved away, that influence remains strong enough to keep our seasons running more or less on schedule. You shift your stance as the planet beneath you sways ever so slightly. Technically, Earth's axis traces a slow circle every 26,000 years, a movement called axial precession. This means the North Star changes over millennia. Today, it's Polaris, but 14,000 years from now, it'll be Vega. Don't worry, it's still a good star, just different. And again, the moon is involved. It doesn't stop the precession, but it helps regulate it, like a metronome in the background, keeping the beat. Now picture a version of Earth without the moon. The tilt starts swinging wildly. Glaciers form where jungles once stood. Rain belts drift across continents unpredictably. Species evolve to adapt and then vanish when the climate flips again. Stability, not a chance. You lie back and look up at the moon, grateful for its quiet influence. It's not flashy. It doesn't shine with its own light, but it plays the long game. It's been moderating Earth's orientation for billions of years, like a planetary life coach whispering, "You're doing great, sweetie," every time Earth starts to get dramatic. And while we're in the mood for obscure historical facts, did you know that ancient Babylonian astronomers were among the first to notice long-term lunar patterns? They didn't understand axial tilt or precession, but they tracked the moon's motion with stunning accuracy. One clay tablet from 400 BCE contains calculations that would make a modern physicist double take. No software, no telescopes, just careful eyes and a lot of patience. It's a reminder that long before telescopes or space probes, humans were already in tune with the moon's calming presence. It showed up every night. It followed patterns. It helped us feel like the universe wasn't completely chaotic. And maybe, just maybe, that's why every culture gave the moon a personality, a face, a name, something more than just a glowing rock in the sky. Because emotionally and geophysically, the moon is our stabilizer. It keeps the planet from tumbling. It keeps the seasons gently shifting. It stops Earth from becoming one of those drama-prone planets that never seems to know what it wants to be. You sit with that thought for a while. Then you notice something. The light. The moon doesn't just reflect, it softens. It smooths the jagged shadows of the night and offers a kind of rhythm the sun never could. No blinding brightness, no punishing heat, just steady, silvery reassurance. As the Earth continues its slow, stable spin beneath you, and the moon paces patiently above, you realize this whole system, this gravitational conversation between Earth and its satellite, is why life could crawl out of the sea and look up at all. The moon doesn't demand attention, but it's always there, just slightly off to the side, like a quiet parent in the back of the school play, mouthing the lines as you go. Without it, Earth might still exist, but the version of Earth you know, the one with seasons, stable climate, and long summer days, that planet needed a little help from its lunar co-star. The fire's out, the cave is quiet. You sit with your back against a cold stone wall, fingers tracing the jagged edge of a flint blade. Outside, the stars are beginning to blink into view, and there it is, the moon. You don't know its name yet. You haven't called it Luna or Selene or anything poetic, but you know what it is. It's the one light that keeps returning. Long before electric lights, before cities buzzed with neon and rooftops glowed with security lamps, the night belonged to the moon. It lit the paths between villages. It guided the hands of early toolmakers and midwives. It cast silver shadows on the backs of sleeping animals. When fire failed and stars hid, the moon was still there, silent, patient, dependable. And right now, in the Paleolithic dark, it's your only torch in the void. You step outside and squint upward. The moon tonight is full and glowing, enormous in a sky scrubbed clean by wind. It's not just a pretty face, it's functionally useful. You and your tribe hunt better by moonlight. You can see predators coming. You can find your way home after sunset. No batteries required. It's hard to imagine now, with headlights and LED street lamps. But there was a time when moonlight was the only nightlight that mattered. Here's your historical fact for the evening. Early human societies timed their activities around the moon's phases long before they tracked solar years. The lunar cycle, about 29.5 days, was simple, visible, and consistent, much easier to follow than the sun's seasonal arc. Some of the oldest human artifacts are lunar calendars, bones with notches that seem to track moon phases. The 44,000-year-old Lebombo bone found in southern Africa is one such example. Carved, notched, counted. A calendar from a time before agriculture, before alphabets, before almost anything. And while scientists debate whether those notches truly represent lunar cycles or something else, menstrual tracking is a strong alternate theory. More on that later. The point is this: the moon was being watched, religiously, repeatedly, long before we knew why. Now you stretch your arms, shake out your legs, and begin to walk. You're moving across a wide, open plain lit only by moonlight. Everything looks flatter in this glow, softer. The trees don't cast dark, jagged shadows. They dissolve into charcoal smudges. The world becomes hushed. This is the moon's true power. It transforms night without banishing it. Unlike the sun, it doesn't scorch or dominate. It reveals gently, a natural dimmer switch for a still wild world. And your quirky tidbit of the night. In low-light conditions, the human eye shifts into scotopic vision, a mode where we rely more on rod cells than cone cells. This lets us see better in darkness, but only in shades of gray, which means that, historically, everyone saw the world in monochrome at night, even under a full moon. The earliest landscapes were painted in shadows and silver. You can understand now why the moon earned so many mythological roles. It was present during moments of danger, of birth, of transition. For the earliest humans, nighttime was filled with unknowns, but the moon became a reliable companion, a beacon, an audience. Across the planet, you start to hear voices, not modern ones, but ancient tongues whispering up at the moon. The Maori of New Zealand speak of Hina, a moon goddess who controls the tides. The Egyptians speak of Khonsu, the lunar traveler and healer. The Chinese admire Chang, who fled to the moon and lives there still, accompanied by a jade rabbit. And in Mesopotamia, the god Sin rides across the heavens each night on a crescent chariot. The moon doesn't just belong to one culture, it belongs to everyone. Historians still argue whether moon worship was universal or merely widespread, but the archaeological record speaks volumes. Temples aligned to lunar events, ceremonies timed to full moons, even early architecture, stone circles, megaliths, often show lunar as well as solar alignments. And what's fascinating is how moonlight became associated with both safety and strangeness. On one hand, it let you see. On the other, it was linked with shapeshifters, madness, and mystery. That's not just poetic flair, it's etymological fact. The word lunacy comes directly from luna, Latin for moon. For centuries, full moons were blamed for mental illness, sleepwalking, hysteria, even crime spikes. Some of those ideas persist today, though modern science hasn't found solid evidence to support them. But if you've ever had a weird night's sleep during a full moon, you're not alone. We'll get to that in section 13. You continue walking, guided by that soft, silvery light. And now you see something ahead, a gathering. Dozens of figures around a low-burning fire, their faces lit not by flames but by the glow above. They're waiting, watching. There's no clock, no calendar, just the moon climbing to its zenith. Tonight is a ritual night. You sit cross-legged among them. No one speaks. The moon is nearing its peak, and you understand instinctively this is the moment that matters. Whether it's a prayer for rain, a harvest blessing, or a burial rite, the timing is deliberate. The moon governs the sacred clock. That's the strange magic of it. Lunar light isn't just useful, it's meaningful. When it shines, things feel different. Nights become ceremonial, time becomes marked. And so you sit with these early watchers, breathing the same cool air, bathed in the same lunar reflection. No matter how far removed you are in time, the experience is the same. A moon, a night, a ritual. It's comforting in a way to know that this glowing sphere has been a shared experience for all of human history. Not changing, not judging, just orbiting, reflecting, waiting for us to look up. The fire burns low. The gathering begins to fade, but the moon, high and whole, remains. And as you close your eyes, still feeling its light through your eyelids, you know this. Even before science had words for what it did, we felt the moon's presence, guiding us, lighting the dark, turning night into something not quite so scary. You open your eyes to a sky that's not quite right. The sun is up, but something's wrong. Its warmth is fading, its light dimming, and the people around you have stopped moving. A hush falls. Chickens roost midday. Crickets start chirping. Dogs whimper, and humans, we stare. Mouths open, breath caught, completely transfixed. Because the moon has done something it doesn't usually do. It has stepped in front of the sun. You're standing in the shadow of a total solar eclipse, and even though you understand what's happening, or at least modern you might, this experience cuts deeper than explanation. It taps into something ancient, primordial, a fear that the universe might be broken and no one's coming to fix it. The moon doesn't glow, it blocks, it steals light, and for a few heart-stopping minutes you're plunged into a sudden, otherworldly twilight. The temperature drops, the air goes still, and the world forgets how to breathe. This isn't just astronomical alignment, it's drama. Cosmic, terrifying, beautiful drama. And early humans, oh, they had thoughts. Historical records show that nearly every ancient civilization experienced eclipses as omens, most of them bad. In Mesopotamia, solar eclipses were believed to predict the death of a king. The Babylonians, detail-obsessed as always, kept meticulous eclipse records and developed the Saros cycle, a method to predict future eclipses with shocking accuracy for the time. But not everyone used math. The Vikings believed that a sky wolf named Skirl chased the sun and sometimes caught it. The Chinese told tales of celestial dragons swallowing the sun whole. In India, it was the demon Rahu seeking revenge. And the fix: make noise, bang drums, light fires, yell into the sky until the moon backed off and gave the sun back. Historians still argue whether early humans understood these events as cyclical or random. Some evidence suggests recurring patterns were noticed, but the emotional weight of an eclipse was so heavy, most societies interpreted them through myth rather than science, which, let's be honest, is kind of more fun. You sit down as the eclipse reaches totality. Everything looks sideways. The horizon glows in a 360-degree sunset. Stars twinkle in midday sky. And above you, the moon wears the sun's light like a glowing crown. It's called the corona, Latin for crown, and it's the only part of the sun that's visible during a total eclipse, like a halo made of plasma. Fun fact, it was during an eclipse in 1919 that astronomers tested Einstein's theory of general relativity. The bending of starlight around the eclipsed sun offered proof that space itself could curve. So yeah, the moon helped confirm one of the biggest physics theories of all time by simply standing in the way at the right moment. Quirky tidbit time. There's a reason eclipses work so perfectly here and basically nowhere else. Earth's moon is 400 times smaller than the sun, but it's also 400 times closer. That's why it appears the same size in the sky, and why total eclipses can happen at all. It's one of those cosmic coincidences that seems designed for spectacle, or maybe just luck. But we won't always have them. The moon is drifting away, slowly, so slowly, but eventually, millions of years from now, total eclipses will stop happening. The moon will look too small to fully cover the sun, and future creatures, if they're still around, will have to settle for partials and annulars. A little less drama, a little less magic. You sigh, knowing you live in a golden window of eclipse perfection. And you're not alone in that wonder. Eclipse records stretch back thousands of years. The ancient Chinese Book of Documents describes a solar eclipse from around 2137 BCE, where royal astronomers were supposedly executed for failing to predict it. Tough gig. The Greeks took a more philosophical approach. Thales of Miletus, sometime around 600 BCE, allegedly predicted an eclipse that stopped a battle mid-fight. Two armies dropped their weapons, looked up, and decided maybe today wasn't the day for war. Hard to argue with the moon when it goes full main character. You stand again, feeling the cool air shift as the eclipse passes. The edge of the sun begins to peek out again, and a diamond of light bursts around the moon's silhouette, called the diamond ring effect. It's stunning, brief, and completely silent. Then it's over. The day returns. Birds shake off their confusion. Humans laugh nervously as if waking from a spell, and the moon keeps on gliding through the sky like nothing happened. But something did happen. Every eclipse leaves a mark, not on the earth but on us. A reminder that the moon is more than a nightlight. It can turn day to night. It can terrify, inspire, confirm theories, and end battles. It can, for a few minutes, make everyone stop whatever they're doing and simply look up. Imagine that. A planet full of noise, distraction, and chaos. And yet the moon, when it wants to, can silence us all. And even now, with apps and live streams and science on tap, the experience hasn't dulled. Ask anyone who stood under a total eclipse, modern or ancient. They'll all tell you the same thing. It doesn't feel normal. It feels like the universe is looking back. As the light fully returns and the warmth hits your face again, you blink against the brightness. And you know, some part of you will never quite look at the moon the same way again. Because now, you've seen what it can do when it decides to steal the sky. The moon is full tonight, and your neighbors are acting strange. Nothing too dramatic, just a little off. That one guy who always keeps to himself is now packing in his backyard. Your dog won't settle, and maybe, just maybe, you feel a little wired too. Can't sleep, can't quite relax. You're not turning into a werewolf or anything, hopefully, but it's enough to make you wonder, does the moon actually mess with us? Welcome to the long, strange history of moon-induced madness. You wander now through the shadowy corridors of human culture, torch in hand, as centuries of superstition whisper from the walls. The word lunatic wasn't picked randomly. It comes from Luna, the Roman goddess of the moon. In Latin, lunaticus originally referred to people thought to be affected by the moon's phases, particularly during the full moon, when strange behaviors, seizures, insomnia, and even violence were believed to spike. And not just in Rome. The Babylonians, Greeks, Chinese, Arabs, all had beliefs linking lunar cycles to mental states. In medieval Europe, it was practically common knowledge. If someone snapped, the moon was probably to blame. Doctors documented it. Judges considered it. Farmers timed planting and harvesting around it, hopping to keep themselves and their crops in check. Historians still argue whether these beliefs were rooted in real patterns or just coincidental timing. After all, when something dramatic happens under a glowing full moon, you tend to remember it. Confirmation bias, absolutely, but it's persistent and powerful. You're now passing through an ancient asylum, not the kind with padded rooms, but an open-air Greek facility built on the belief that nature could heal. Patients here are encouraged to sleep under the stars. One physician recommends exposure to the moon's cooling light to balance overheated minds. Another warns that too much moonlight causes melancholia of the blood. So, proceed with caution. Fast forward to the 1700s and 1800s, and things get oddly official. In England, there were even laws recognizing the idea of temporary lunacy. If someone committed a crime during a full moon, they might receive a lighter sentence. No joke. Quirky science tidbit. There's a tiny crustacean called the Lunella smaragdus, a moon snail found in New Zealand, that actually feeds according to the lunar cycle. It's not alone. Crabs, coral, and certain worms all time reproduction or migration with lunar phases. So while humans might not sprout claws and howl, other creatures definitely march to the moon's beat. Now, let's dip into some actual data. Do modern studies show a spike in madness during full moons? Well, maybe not madness exactly. Sleep disruption, yes. A few studies suggest people take longer to fall asleep and get less deep sleep during full moons, even in rooms without windows. The cause, unclear. The light, the cycle, or maybe something buried in our evolutionary wiring. Then there's behavior. Police logs, ER records, hospital admissions, they've all been studied for lunar patterns. The results? Mixed. Some show minor upticks in aggression or accidents. Others find absolutely nothing. Science is still on the fence. And yet, even seasoned ER nurses, police officers, and firefighters swear that full moon nights are just weird. More stabbings, more chaos, more Florida man behavior. Coincidence? Possibly. But try telling that to someone working the night shift on a full moon. Back to you now, walking through a moonlit village in, let's say, 14th century Europe. A dog barks. A woman closes her shutters. Someone mutters about spirits being restless tonight. You pass a well where a young man is staring into the water, murmuring to himself. The townspeople keep their distance. You realize something important. Even if the moon isn't causing these things, it's giving people permission to believe, permission to let go of normal. Because moonlight is different. Sunlight tells you what to do, wake up, get moving, photosynthesize if you're into that sort of thing. But moonlight, it suggests something quieter, stranger. It's a mirror without warmth, a reflection that doesn't explain itself. And in that silvery, ambiguous light, the rules feel looser. Here's a fun literary aside. Shakespeare loved the moon. He used it in A Midsummer Night's Dream, Othello, Hamlet, often to signal instability, romance, or illusion. When characters go mad, fall in love, or make terrible decisions, odds are the moon's hanging around somewhere in the background. You arrive now at a mountaintop observatory, telescopes pointed upward. A modern astronomer stands beside you, sipping lukewarm coffee and rolling their eyes. No, the moon doesn't make people crazy, they say. At least not directly. But then they pause. Still, I won't lie. The observatory gets strange calls during full moons, more than usual. They shrug. I blame the lighting. The moon, they explain, doesn't just pull at the oceans. It pulls at emotion, at imagination. It's become the ultimate cosmic Rorschach test. Whatever you project onto it, it seems to reflect back. You look up again. That full moon hangs motionless, glowing like a guilty smile. You can't help but feel something in your bones. Maybe it's ancient instinct. Maybe it's superstition. Or maybe it's just the brain reacting to a night that isn't fully dark. In any case, the moon doesn't mind your curiosity, or your weird energy, or your sleeplessness. It's been watching for a long, long time. So if tonight feels just a little strange, maybe let it. You're crouched now in the dust of a cave floor, watching as someone scratches lines into a long, pale bone. Their fingers are stained with ash and ochre. Each notch is deliberate. Cut, breathe, cut again. It's quiet except for the occasional drip of water echoing off the walls. Outside, the moon hangs just above the horizon, not quite full, not quite new. The person beside you leans back, studies their work, then adds another mark. You've just witnessed one of the first attempts to track time, not with numbers or clocks, but with the moon. And it wasn't a one-off. All around the ancient world, humans were following the moon's rhythm, not just for tides or hunting or storytelling, but for something more personal, more internal. Because somewhere along the line we realized our bodies were dancing to the same cycle. Tonight, you're diving into one of the moon's oldest and most intimate partnerships, its mysterious link with menstruation. Let's start with the obvious. The average menstrual cycle is about 29.5 days, the exact length of a synodic lunar month. Coincidence? Maybe. But if you're human and you notice that your body's rhythm matches the moon's glow, you don't just shrug and walk away. You pay attention. You make marks. You start to map your life around it. Some of the earliest objects interpreted as lunar calendars, like the Ishango bone, dated to around 20,000 years ago, feature groupings of notches that may correspond to lunar phases and possibly to menstrual cycles. Historians still argue whether these notches truly reflect menstrual awareness or are simply moon tracking for hunting or weather. But the overlap is hard to ignore, especially when your life and fertility depends on timing. You watch now as a small group gathers by the cave entrance. There's no written language, no formal ritual, but something is happening. A young woman steps out under the moonlight and the others make space. Some cultures, past and present, have treated menstruation as sacred, others as taboo. But the moon is there for all of them, cycling steadily through its phases like a quiet metronome for human biology. Here's your quirky tidbit. Some species of coral spawn according to lunar phases, literally releasing their eggs and sperm into the ocean on the night of the full moon. It's like a synchronized underwater rave. And while humans don't spawn under moonlight, thankfully, we do still carry echoes of lunar timing in our hormonal rhythms, sleep, and reproductive cycles. You move forward in time now, from cave etchings to ancient temples. In Mesopotamia, the moon god Sin was often associated not just with timekeeping, but with fertility. In Egypt, the goddess Isis, associated with the moon, represented motherhood and magic. And in the Greco-Roman world, lunar goddesses like Selene, Artemis, and Diana were often linked with childbirth, cycles, and the wild feminine. The moon wasn't just a rock, it was the body's celestial twin. And if you were an early farmer or healer, you noticed patterns. You noticed that some people's cycles aligned with the full moon, others with the new. You started making connections. Maybe a full moon birth was lucky. Maybe a new moon was for rest. Even today, some midwives swear that more babies come during full moons, though studies haven't consistently confirmed this. And still, the belief persists. And not just about birth. Even the word menses comes from the Latin mensis, meaning month, a word that itself is rooted in month. So every time you refer to monthly cycles, you're invoking the moon whether you realize it or not. You walk now through a Neolithic village past stone huts and fire pits. On a table lies a flat stone with carvings, a rough lunar calendar. A woman is teaching her daughter how to read it. "Here," she says, pointing. "This is when we rest. This is when we plant. This is when we bleed." The moon isn't mystical to her. It's practical. It's a body clock written in the sky. And here's something strange. Studies in modern times have shown that menstrual cycles can resynchronize with the moon under certain conditions. Remove artificial lighting, avoid digital screens, and your body's natural cycle may slowly drift back toward the lunar one. Not for everyone, but for enough to make scientists raise an eyebrow. Even in the 20th century, anthropologist Margaret Mead observed lunar rituals in various cultures that included synchronized gatherings of women during particular moon phases, often for rest, healing, or storytelling. The moon wasn't just a light, it was a communal signal. Imagine that for a second. A whole society where the moon tells you when to retreat, when to gather, when to heal. A quiet lunar socialism of the body. And yes, it's worth noting that not all bodies cycle this way. Not all people who menstruate do so on a lunar timeline. Hormonal shifts, birth control, and modern light pollution can scramble the natural rhythm. But the cultural memory of that connection, it lingers. The moon was never just about the sky. It was about us. About knowing ourselves in relation to something bigger and slower. You sit now beside a still pond, full moon reflected in the surface. You watch the ripples of your breath disturb the water, and for a moment you feel it, that ancient recognition. Your body is made of water. The moon moves water. Why not you too? Not with tides, but with timing. Cycles within cycles. A rock in space. A pulse in your chest. All moving together, quietly, invisibly. And somewhere deep in your evolutionary memory, you know, the moon was never just a guide for light or time. It was the first calendar carved into the flesh. You find yourself in the middle of a wide, open field. The soil is dark and rich beneath your feet, still warm from the afternoon sun. The air smells like damp earth and hay. Nearby, someone kneels with a bundle of seeds in hand, casting quick glances toward the sky, not at the sun this time, but at the moon. It's waxing tonight, a clean, bright crescent rising higher with each hour. That's good. It means it's time to plant. You're in the age of early agriculture now, long past the nomadic hunting bands and cave paintings. Villages have formed, people stay in one place, and the rhythm of life is no longer just about tracking herds or surviving winters. It's about timing crops, and once again, the moon takes center stage. See, before clocks, calendars, or farmers' almanacs, people looked up. The moon became a tool for farming, its phases woven into sowing rituals, harvest ceremonies, and seasonal migration patterns. You walk past rows of barley and millet as farmers debate whether the moon is right for planting root vegetables. Some swear by the waxing moon. When the light is growing, it's best to plant things that grow above ground. Leafy greens, fruiting plants. When the moon is waning, that's for roots. Carrots, onions, things that dive into the earth just as the moon's light retreats. Historians still argue whether lunar agriculture had actual measurable effects. Modern studies are mixed. Some show no impact. Others hint at subtle growth differences. But for the early farmers, the moon wasn't just superstition. It was the most reliable calendar they had. And here's your historical nugget. One of the oldest agricultural calendars we know of, the Coligny calendar, used by the ancient Gauls around 200 CE, was entirely lunar-based. Carved in bronze, it tracked months, moon phases, and special festival days. No sun worship here, just moon cycles and planting rituals. And that wasn't just a Celtic thing. The ancient Mayans tracked lunar eclipses and phases alongside their elaborate solar calendars. In China, rice farmers still plant according to lunar traditions that have been passed down for thousands of years. And in India, many Hindu festivals and crop timing rituals are still linked to the moon, not the sun. You pause by a low stone wall where a woman in a linen tunic is checking her seed bag. She tells you, matter-of-factly, that the moon tells the seeds when to grow. You don't correct her. She might not have photosynthesis charts or soil chemistry apps, but she's got something else, a rhythm that's worked for generations. Here's your quirky tidbit for the evening. Some modern biodynamic farmers, notably those following the practices of philosopher Rudolf Steiner, still plant, harvest, and prune according to astrological moon calendars. They divide days into root, leaf, flower, and fruit days based on moon position and zodiac signs. Sounds a little mystical, sure, but some winemakers in France and Germany swear the grapes know the difference. As you walk deeper into the field, you notice something odd. The crops aren't planted in perfect rows. They follow a subtle curve, aligned with lunar rise points on the horizon. These farmers don't just plant by phase, they plant by direction, using the moon's rising arc to guide spacing and growth. You stop and look up. The moon is climbing slowly, casting long shadows from each sprouting stalk. And suddenly you realize the moon wasn't just a passive background object. It was a planner, a seasonal clock, and, let's be honest, a bit of a micromanager. But in a good way. Because when you live close to the land, everything matters. When to cut hay, when to wean livestock, when to burn fields, when to let them rest. And the moon, with its precise 29.5-day cycle, gave you a repeating pattern to work with. New moon to full moon and back again. Wash, rinse, grow, repeat. Even fishing was governed by lunar cues. Ocean tides, of course, respond directly to the moon's pull. But freshwater fishing, still lunar. Many cultures noticed that fish fed more actively during full or new moons, especially at moonrise and moonset. In parts of Indonesia and the Philippines, traditional fishers still time their outings with moon tables. Historians point out that one of the earliest human transitions, from foraging to farming, may have relied heavily on lunar timing. You can't plant successfully if you don't understand seasonality. And if you don't have writing or clocks, your best guide is a glowing calendar in the sky. Reliable, predictable, always returning. You crouch beside a little seedling pushing up through the soil. It's fragile now, just 2 leaves trembling in the breeze. But give it time, give it moonlight, and it will thrive. It doesn't know about gravity or lunar pull. It just knows when to grow. That's the beauty of this connection. It isn't flashy, it's gentle. The moon doesn't demand growth, it suggests it. It doesn't bark orders. It hums a lullaby of light and shadow, and the earth responds in kind. You walk back toward the edge of the field now, the smell of soil and herbs drifting behind you. The farmers are packing up for the night, leaving their tools in neat bundles. Someone glances up at the sky and nods. "Good moon tonight," they say, as if talking about the weather, as if the moon is a neighbor, a familiar, an ally. And maybe it is. Because whether or not science can prove every moon-based planting belief, one thing is certain: the moon gave us rhythm, routine, a way to look up and decide now is the time, not later, not randomly, now. And as you lie in the grass, watching the moon arc higher, you can't help but feel the echo of that certainty in your chest. A silent drumbeat, older than writing, older than kings. Grow, wait, rest, repeat. You're knee-deep in something wet and squishy, not exactly glamorous. Seaweed wraps around your ankles, little crabs skitter past your toes, and somewhere nearby, something makes a soft gloop sound you'd rather not investigate. Welcome to the intertidal zone, a messy, mucky, miraculous strip of coastline that wouldn't exist without the moon. Twice a day, like clockwork, the ocean rushes in, flooding the shore. And twice a day, it retreats, barring the rocks and revealing tidepools full of secrets. This daily rising and falling of the sea, orchestrated by the moon's gravitational pull, creates tidal ecosystems, some of the most biologically diverse environments on the planet. And you, lucky time traveler, have arrived right when the tide is going out. Around you, nature is putting on a show. Anemones close up tight, trapping drops of water in their tentacles. Starfish cling to rocks like lazy ceiling fans. Tiny fish dart into leftover puddles. And above it all, seagulls cackle as they descend like feathery opportunists. This chaotic zone, sometimes wet, sometimes dry, turns out to be one of the best classrooms evolution ever built. Why? Because living here is hard. You need to handle both drowning and dehydration, salinity shifts, temperature swings, predators, and crashing waves. The moon doesn't make life easy in the intertidal zone, but it makes survival here meaningful. Organisms adapt, specialize, evolve. It's natural selection on a 2-times-a-day schedule. Here's your quirky science tidbit. The grunion, a small silver fish native to California, actually spawns on the beach. During full and new moons, when tides are highest, they ride the waves ashore at night, lay their eggs in the sand, then flop back into the sea. The eggs hatch 2 weeks later, just in time for the next big tide. It's like their entire existence is choreographed by the moon's gravitational ballet. You climb now onto a rock ledge just above the tide line and look out over the receding water. These poolsing zones, expanding and shrinking with the tides, aren't just pretty. They're crucibles, safe-ish zones where early life could test the leap from water to land. Scientists believe these intertidal zones may have been key in the transition from aquatic life to terrestrial life. Think about it. Here, in these small, shallow pools, early organisms could find oxygen, light, and isolation. Mutations happened. Limbs formed. Gills adapted. It was a living laboratory, renewed twice a day. Historians, evolutionary biologists in this case, still argue whether life first stepped onto land in tidal zones or freshwater river banks. But the moon's role in shaping coastal niches is undeniable. No moon, no strong tides. No tides, no shifting shores. No shifting shores, maybe no us. You step carefully across the rocks now, watching hermit crabs play an eternal game of real estate. Each little creature, each adapted shell and behavior is an echo of this lunar rhythm. The moon pulls and the shore answers. And the moon doesn't just pull water, it stretches the earth itself. Yep, land tides are real. The solid crust of the earth bulges ever so slightly in response to the moon's gravity, up to 40 centimeters in some areas. You don't feel it, but it's happening beneath your feet. A gentle planetary inhale and exhale. You pause at a tide pool the size of a bathtub. Inside, a whole world unfolds. Barnacles opening and closing like tiny trap doors, algae drifting like underwater curtains, and a single blenny fish staring at you like you owe it rent. This isn't just scenery. It's a snapshot of what life looked like before land. The ancestors of insects, amphibians, and even mammals likely spent time in places like this, clinging to life between two extremes, wet and dry. And here's a fun historical note. Charles Darwin, on his voyage aboard the Beagle, was fascinated by tidal ecosystems. He spent hours poking around in them, marveling at barnacle diversity. He even wrote a multi-volume book on barnacles before publishing on the origin of species. So yes, the moon, in a roundabout way, helped keep Darwin ankle-deep in goop until he figured out evolution. Now the tide is starting to come back in. You watch as the water creeps forward, erasing the pools, covering the crabs, folding everything back into the sea. In a few hours, it'll retreat again, and the cycle will repeat. But for now, the moon calls the ocean home, and the ocean obeys. This is the moon's quiet masterpiece. It sculpts coastlines, feeds marshes, shapes migration routes, and opens temporary worlds where evolution takes baby steps toward complexity. It's not flashy, but it's everywhere. A gravitational artist painting with water and sand. You turn and walk inland now, the tide brushing your heels. Salt clings to your skin. The sound of the waves grows softer behind you. And even though you're leaving the beach, you realize that most of the life you know, including you, owes a debt to this exact border zone, where water meets air, where timing matters, where the moon plays tug-of-war with gravity and life responds by inventing new shapes. The moon didn't just help life begin. It gave life a stage, and then it raised the curtain. You're swaying in a canoe now somewhere in the open sea. The sky is dark, star-thick, and endless. The moon is rising, low and golden, a fat coin just above the water's edge. It casts a shimmering path across the waves like a glowing road to somewhere else. You dip your fingers into the water and feel the current tug gently. It's not just the wind, it's the moon. Again. Tonight, you're paddling alongside some of the first great explorers, humans who used the moon not just for farming or storytelling, but for migration, movement, discovery. Without ever needing a compass, without any written maps, they followed patterns written in the stars and on the tides, trusting the moon's rhythm to guide their journey across thousands of miles of open ocean. And somehow it worked. You glance up and see a navigator, barefoot, quiet, hands resting on his thighs, reading the sky. He doesn't check a clock. He checks the moon's position, the timing of its rise and set, the shape of its crescent. He knows how the tides will behave for the next several days. He knows which swells are born from wind, which from distant storms, and which from the deep, rolling breath of the moon. You're now inside the brilliance of Polynesian navigation, one of humanity's greatest achievements. Long before GPS or sextants, seafarers from islands like Hawaii, Tahiti, and Samoa used the moon, stars, and oceans swell patterns to migrate thousands of miles across the Pacific. No metal tools, no motors, just boats, guts, and lunar rhythm. And they weren't alone. Coastal cultures across the globe have followed the moon's lead for millennia. Viking seafarers tracked tides and moon phases as they crossed from Scandinavia to the British Isles and beyond. Arab traders in the Indian Ocean navigated monsoons and tidal patterns shaped by lunar cycles. West African fishermen knew which moon meant high fish activity and when to stay ashore. Because here's the truth. Without the moon, large-scale migration by sea would have been tricky, even dangerous. You see, the moon doesn't just tug on the water. It creates predictable tidal currents, the slow-moving rivers within the ocean itself. These currents can either carry you home or strand you forever, depending on whether you've timed your voyage right. Historians still argue whether ancient migration routes were charted with conscious tidal timing, or whether people simply noticed what worked and passed it down. Either way, the result was extraordinary. The spread of humanity across islands, continents, and new worlds, always with one eye on the sky. Quirky science tidbit: in certain narrow straits, like the Bay of Fundy or the English Channel, tidal currents can reach up to 10 knots, faster than most early boats could row. Knowing the moon's cycle meant knowing exactly when to launch. If you missed the window, you could literally be rowing in place for hours. Now the moonlight deepens, silvering the water and turning the wave tops into ink brush strokes. You watch as flying fish skitter across the surface, chased by nothing, or maybe just by the moon's reflection. Behind you, the navigator begins a quiet chant, not for the crew but for the sea. It's part timing, part memory. Each verse describes stars, winds, moons, and directions. It's not a song, it's a map. This is called a star compass, and the moon plays a supporting role. Its phases mark time, and its path across the sky signals night direction. In some Pacific traditions, navigators also use lunar halos, rings of light around the moon caused by ice crystals, as short-term weather indicators. A thick halo, rain coming. Time your sail accordingly. Even inland, migration wasn't immune to lunar logic. Herding societies followed seasonal routes often tied to water availability, which, surprise, can be influenced by snowmelt, rainfall, and tidal estuaries, all gently nudged by the moon's gravitational whisper. You land now on a beach that wasn't here 6 hours ago. The tide has pulled back, revealing flat sand and stranded kelp. Your canoe glides to a stop, nose scraping softly into this temporary shoreline. The people disembark, unloading their gear swiftly. They've done this before. They know that soon the moon will shift and the ocean will come reclaim this land. They don't need watches. They don't need warnings. They've been watching the moon since long before they could write about it. They know. And so do you. You glance up once more. The moon is higher now, wider, sharper. It's not just a nightlight, it's a compass, a clock, a calendar, and if we're being honest, a bit of a show-off. Because who else could direct migrations across oceans, signal the start of fishing season, and still make a beach picnic feel romantic? Here's a little historical fun fact to tuck under your travel pillow. In ancient Japan, fishermen would hold moon-viewing parties in boats, called tsukimi-byun, to both honor the moon and increase their catch. A full moon meant better fishing, smoother tides, and a spiritual bonus of good fortune. And maybe that's the most beautiful part of all this. The moon didn't just shape migration in a logistical sense, it gave it meaning. It turned voyages into ceremonies, departures into rituals, journeys into shared stories. You lie back in the sand now, the canoe pulled up beside you. The tide will return soon, gently pulled by that ever-watchful eye in the sky. But for now, you rest, knowing that wherever humans have moved, by foot, by paddle, by sail, the moon has gone ahead, lighting the path, shifting the seas, whispering, "You go. Now is the time." And we listened. You're lying in bed now. Not on a beach, not in a cave, not in a canoe. Just your bed, blanket twisted around your legs, pillow a little too warm, the room dim but not dark. Moonlight slips through the curtain, soft and silver, landing right across your face like it knows exactly what it's doing. And you are wide awake. Welcome to the deeply inconvenient mystery of how the moon messes with your sleep. It's been one of those nights. No caffeine, no stress, no raccoons outside your window as far as you know, and yet your brain feels like it's hosting a small indoor rave. You flip the pillow. You try counting sheep. You turn on a podcast, nothing helps. But then you check the calendar. Live. The full moon. Coincidence? Or is the moon still pulling strings in your brain, even when you're not looking? Let's rewind. For millennia, humans suspected a link between lunar phases and sleep. You heard whispers of it back in the asylum corridors and moonlit villages. But now, in the electric-lit, screen-saturated present, surely the moon can't possibly still be affecting us, right? Except maybe it can. In 2013, a small but memorable Swiss study threw sleepy science into a tizzy. Researchers found that during full moons, participants took longer to fall asleep, got less deep sleep, and slept for less time overall, even in complete darkness with no view of the moon at all. Weird, right? Historians still argue whether this effect is evolutionary, biological, or just an incredibly persistent example of confirmation bias. But more studies have followed. Some confirm the sleep disruption, others don't. Some show subtle changes in melatonin levels, that's your sleepy hormone, and REM cycles. Others wave it off as statistical noise. Still, you're not imagining things. Not entirely. Here's your quirky tidbit for the night. Certain amphibians and insects sync their behaviors with the moon. Some frogs call louder. Some moths navigate differently. Even plankton migrate vertically in the ocean every night, adjusting their patterns based on lunar phase. So maybe your restless tossing is just a deeply buried response from some ancient evolutionary cousin that got eaten under a full moon. The truth is, our bodies are sensitive to light, especially blue and white light, like the kind moonlight reflects. Before electricity, moonlight was the brightest thing available at night. It dictated when to hunt, when to gather, when to stay in the safety of the shadows. And even though we now have blackout curtains and alarm clocks, that rhythm still lingers in our wiring. You step out of bed now and wander to the window. The moon is glaring like a sleepy-time saboteur, full and smug, lighting up rooftops and tree limbs like stage props. You look around your neighborhood. A few lights are on. You wonder if your neighbors are awake too, staring at their ceilings, wondering why they feel like someone flipped their internal switch to vague existential hum. Fun fact: in traditional Chinese medicine, full moons are said to increase yang energy, making people more active, emotionally sensitive, and prone to insomnia. Ayurvedic tradition in India also acknowledges lunar effects on mental clarity and physical restlessness. Not medical consensus, but cultural patterns that go back centuries. And the weird thing, they're all saying the same thing: full moon equals brain won't chill. Of course, we can't forget mood. Plenty of people report feeling more emotional, more impulsive, or just more extra under a full moon. Police and ER staff still brace for it, even if the data wobbles on whether there's an actual uptick in chaos. Nurses tell stories of patients getting agitated. Teachers whisper about restless classrooms. Pet owners swear their dogs go full goblin. Is it the moon? Is it us expecting the moon to do something weird and then noticing every weird thing? That's the hard part. Human brains are pattern hunters. If something unusual happens during a full moon, we remember it. If it doesn't, we shrug and move on. Our brains are basically Reddit threads in the dark, upvoting the weird stuff and burying the normal. You lie back down. Moonlight still leaks through. You try to remember when you last slept really well. Was it a waning crescent? A new moon? Maybe it's time to keep a moon journal, something the ancients would approve of. Day 3, slept like a rock. Moon was chill. Day 14, launched into the emotional stratosphere because I burned my toast. Moon full and clearly plotting. You smile in the dark. The moon doesn't actually care if you sleep. It just keeps doing its thing, waxing, waning, pulling at tides and maybe your hypothalamus. And yet, even the suggestion that it's influencing you is enough to make you feel watched. Not in a creepy way. in a cosmic roommate kind of way. It's like sharing an apartment with someone who never speaks, but still manages to throw off your vibe by changing the lighting every few nights. You shift again under the blanket, half lulled by the glow, half mutinous about being awake. But here's something lovely to think about. All those times you've lain awake during a full moon, you're not alone. You're sharing that restlessness with every human who's ever rolled over in their hay-stuffed mattress or wool blanket and whispered, not again." You're part of an ancient club, one where the moon taps you lightly on the shoulder and says, "Hey, just checking if you're still human." So if you can't sleep, don't fight it. Breathe. Watch the glow. Count the shadows. Feel the moon doing its weird thing overhead. Eventually, your body will give in. The moon will continue on its path. And you'll dream of tides, of cycles, of fish leaping under silver light, of a planet that sleeps in rhythm with its oldest friend. You're floating now, not in your bed this time, but in space. Out here, the silence is thick. There's no breeze, no bird song, no hum of a city in the distance. Just you, your thoughts, and the distant, beautiful curve of Earth behind you. But you're not looking at Earth right now. You're looking toward its neighbor. No, not Venus, not Mars. You're eyeing Phobos and Deimos, the two tiny, potato-shaped moons of Mars. And if we're being honest, they look a bit tragic. Tonight, you're taking a moment to appreciate just how lucky Earth got with our moon by comparing it to the lunar consolation prizes of other planets. Let's start with Mars. Phobos and Deimos sound cool, ominous, mysterious, like they should each have a dramatic theme song. But in reality, they're more like space rubble. Phobos is about 22 kilometers wide, tiny, full of craters, shocking, and orbiting so close to Mars that it rises and sets multiple times a day. Deimos is even smaller and more distant, quietly drifting along like a moon-shaped afterthought. You picture trying to navigate ancient oceans with those things in the sky. Not happening. They're too small to be useful for tides, too irregular to provide consistent light, and too lumpy to inspire poetry. No offense, Mars. You drift farther now to Jupiter, a gas giant with 95 moons. You'd think statistically one of them would be a solid Earth-Moon rival. But here's the thing, quantity doesn't mean quality. Jupiter's moons are mostly gravitationally bullied by the planet itself. Sure, Ganymede is the biggest moon in the solar system. And yes, Europa might have an ocean under its ice, but neither creates stable planetary tides, and none are tidally locked in the way Earth's moon is. Because here's the kicker, Earth's moon isn't just big, it's proportionally enormous. It's about 1/4 the diameter of Earth, and its mass is about 1/80 of the planet. That's a staggering ratio. No other planet-moon pair comes close. your quirky space tidbit of the evening. Some scientists consider the Earth-Moon system a double planet, not just a planet and its satellite. Because the Moon doesn't just orbit Earth, the two bodies orbit a shared center of gravity called the barycenter, located about 1,700 kilometers beneath Earth's surface. Not dead center, just enough off balance to make Earth do a little lunar dance. Historians, or more precisely, planetary scientists, still debate whether this Moon-to-Earth ratio is rare in the universe. After all, we've only really studied one solar system up close, but so far, nothing else quite like it has shown up. You drift now toward Venus. Surely Earth's sister planet has a similar setup. Nope, Venus has no moon at all. Zero. Not even a sad little space rock. Just a lonely, hot, slow-spinning orb, wrapped in clouds of sulfuric acid and regret. Some theories suggest Venus used to have a moon, possibly lost in a massive impact that reversed the planet's rotation. Others argue it never had one. Either way, the result is a planet that wobbles like a broken top and spins so slowly that a single day lasts longer than a Venusian year. Not exactly ideal conditions for life. Then there's Mercury, also moonless, too small, too close to the sun. Even if it had a moon once, solar gravity likely stole it long ago. So back you go, gently gliding toward your home planet. And there it is, the familiar duo. Earth swirling in greens and blues and whites. And the Moon, silvery and whole, always facing the same way, always keeping time. The Moon does something that few other moons can manage. It stabilizes its host planet's tilt, controls strong ocean tides, reflects significant light at night, and has just enough visual size and symmetry to occasionally cause perfect solar eclipses. That's an overachiever, folks. You float in awe watching them spin together in a cosmic waltz. You realize that no other moon, not Phobos, not Deimos, not Europa or Titan or any of Saturn's icy snowballs, has quite this kind of relationship with its planet. Most moons are too small, too erratic, too far. They orbit like forgotten accessories. Ours. It's a partner. And this partnership isn't just nice. It may have been necessary. Many scientists believe Earth's moon played a critical role in shaping life as we know it. You've already explored some of those threads: tides, tilt, timekeeping, protection from impacts. But when you look at the other planets, you see what happens when those threads are missing. No moon equals an unstable spin, weak or non-existent tides, no nightlight, no rhythm. You don't want to live on those worlds, not unless you enjoy chaos, climate swings, and extremely poor visibility at night. Your thoughts drift now to the future, when we send humans to Mars or beyond. We'll miss our moon, not just as a companion but as a shield. Yes, here's one more quirky science point for the road. The moon helps protect Earth from impacts. Its gravity subtly deflects asteroids, and its own surface has taken thousands of hits meant for us. Those craters aren't just decoration, they're cosmic battle scars. The moon, quite literally, takes one for the team. And someday, when we terraform distant worlds, you can bet we'll try to recreate what Earth and the moon have together. Artificial tidal forces, simulated light cycles, orbital stabilizers. Because once you've had a moon like ours, you'll never settle for less. So you turn your gaze back to Earth now, the moon beside it like a loyal guardian, and you smile. Other planets may have moons, but none have this moon. This quietly powerful, perfectly placed, utterly improbable moon. And now that you've seen what else is out there, you understand. You live on a world that won the lunar lottery. You're drifting again, but this time you're not just moving through space. You're moving through possibility. Past stars and ice giants, beyond Saturn's golden rings, deeper than the Kuiper belt, where sunlight starts to feel more like suggestion than fact. And there, scattered among the exoplanets and rogue rocks, you find them, moonless worlds. Beautiful, barren, and frankly doomed. Tonight, you're visiting the planets that never had a moon, or lost theirs, or never got the memo that a gravitational sidekick was essential. And spoiler, they're not doing great. From the outside, some of them look just fine. Blue, maybe, cloudy, possibly warm. But as you dip into their atmospheres or try to, you discover the truth. Something's missing. Something you've probably taken for granted your entire life. Because without a moon, life has a much harder time showing up. And even if it does, it struggles to stick around. Let's break it down. Imagine an Earth-like planet with no moon. The first thing to go, tidal rhythm. Tides on Earth are largely lunar. Sure, the sun helps, but the moon contributes about 2/3 of the gravitational force that makes tides rise and fall. No moon, and your beautiful coastlines become stale puddles. No dynamic mixing of nutrients, no intertidal zones, no tidal estuaries bursting with biodiversity. In other words, you lose life's shoreline laboratory, that cradle where evolution took some of its boldest steps. You float above one of these sad planets now. The ocean is flat, eerily calm, no tidal cycle to stir things up. The shallows are lifeless, no coral reefs, no migrating fish, no moonlit spawning frenzies, just water standing still. Now let's talk axial tilt. If a moonless planet spins even a little off-center, there's nothing to stabilize it. Earth's tilt, 23.5 degrees, gives us seasons, weather cycles, migration patterns. But on a moonless Earth, that tilt might swing wildly every few million years. Historians, okay, planetary scientists again, still argue just how wild it could get. Some models suggest a swing of up to 90 degrees. That's not flip-flops in January kind of wild. That, the poles becoming the equator wild. You circle a moonless world that's been caught in one of these tilt tantrums. A few million years ago, it was warm and wet. Now it's frozen from pole to pole. Later, it might swing back, melt everything, drown the continents, and evaporate its oceans. Repeat as needed. Not ideal if you're trying to build a stable ecosystem, or, raise a family. But there's more. No moon also means faster spin. Remember back in section 4 when Earth's days were only 6 hours long. That's your reality on a moonless planet. Without tidal breaking, the planet stays jittery and quick. Days race by, nights never last. Photosynthesis struggles. Temperature swings become brutal. As sleep cycles, good luck. You hover now above a world where the sun rises and sets every 3 hours. Nothing has time to grow. Light shifts too fast. It's like evolution pressed fast forward and broke the button. And here's your quirky science tidbit of the evening. Some exoplanets we've observed seem habitable, right size, right distance from their star, but they're likely tidally locked to that star. One side faces eternal daylight, the other eternal night. Why? Because they have no moon to stabilize their spin. No tug of war, just one slow, lopsided twirl. The day side bakes, the night side freezes. Life might exist on the border in the Terminator zone, but it's unlikely to thrive. Now you dip into a few alien atmospheres. One smells scorched, full of carbon dioxide and sulfur. Another is thin, barely able to hold onto its gases. On Earth, the moon may have played a subtle role in helping retain our atmosphere by stabilizing the planet's spin and shielding us from extreme impacts. Which brings us to the last gift you lose without a moon: protection. Our moon absorbs countless asteroid impacts. Its cratered surface is a resume of near misses, things that might have destroyed us if not for our trusty sidekick. A moonless planet is basically an open target. No gravity buffer, no friendly meat shield. Just you, your fragile biosphere, and space rocks playing cosmic dodgeball. And while we're talking long-term danger, on a moonless world, solar radiation can become a bigger problem. Some theories suggest Earth's early magnetic field may have been stabilized in part by tidal heating from the moon. No tides, no geodynamo. No geodynamo, no magnetosphere. And without that, the solar wind strips your atmosphere like paint from a weathered sign. Now you drift back toward Earth, your home. It glows like it always does, blue and breathing, with the moon quietly packing alongside. It's not a coincidence that life arose here. It's not just luck, it's structure, rhythm, a Goldilocks combo of ingredients, and one of the biggest scoops of that mix was lunar. And yes, historians still debate exactly how critical the moon was. Could life have formed without it? Possibly. Could it have become complex? Maybe. But thrived, diversified, built civilizations, lit cities, tracked calendars, launched rockets. Unlikely. Because the moon didn't just shape Earth. It shaped how we understand time, direction, and self. A world without a moon is like a song without tempo. Notes, yes, but no rhythm. So the next time someone says it's just a rock, smile politely, then tell them about the planets that never got a moon. The ones that tilted too far, spun too fast, or fell into silence. The ones that could have been homes and aren't. Then look up. Because you live on a planet with a tide caller, a calendar keeper, a spin stabilizer, a nightlight, and a bodyguard. You live on a planet with a moon. And that has made all the difference. You're standing in a stark white room now, under bright artificial lights. Everything smells faintly like metal and dust. In front of you, behind thick glass, sits a single rock, gray, jagged, quietly unimpressed by your presence. It doesn't sparkle, it doesn't glow, it doesn't hum with ancient power. But this is no ordinary rock. This one came from the moon. Tonight, you're getting your fingers metaphorically dusty with the oldest time capsule Earth never got to keep for itself. Because lunar rocks, while technically alien, are some of the best records of Earth's own origin. Go ahead, lean closer. This piece of moon was brought back by the Apollo 17 mission in 1972. It's older than any rock we've found on Earth's surface. That's because the moon, unlike Earth, doesn't recycle its crust. It doesn't have rain or rivers or plate tectonics. It's a geological hoarder, preserving its ancient face for billions of years. And what it remembers, we've only just begun to understand. Back in 1969, when Apollo 11 astronauts collected the first lunar samples, no one was quite sure what they'd find. Was the moon volcanic? Was it coated in space dust? Was it cheese? Okay, probably not cheese, but hey, people asked. What they found instead was a mirror, not of Earth's surface, but of its early history. These rocks carried chemical signatures nearly identical to Earth's mantle. Same oxygen isotopes, same basic ingredients. And that, in part, is how we confirmed the giant impact hypothesis you floated through in Section 2. Here's your quirky science nugget. One of the rocks from Apollo 14, sample 14,321, known as Big Bertha, contains a tiny fragment of quartz and zircon embedded inside it. It's possibly a chunk of Earth's own ancient crust, ejected into space by an asteroid impact and later absorbed by the forming moon. So yes, you're looking at a piece of Earth that spent 4 billion years living on the moon, like a cosmic airman guest that never checked out. As you walk down the display hall, other moon rocks whisper their stories. Some are anorthosites, bright and reflective, formed from the moon's original crust when its surface was still a vast ocean of molten rock. Others are basalts, dark and dense, solidified from lava that seeped across lunar plains during later volcanic activity. Historians still argue whether the moon had a long volcanic life or just a few short tantrums in its youth. Some evidence suggests volcanic activity may have lasted longer than we thought, possibly as recently as 1 billion years ago. Not bad for a rock with no atmosphere. And while these samples may not be beautiful in the glittery sense, they're stunning in another way. They give us a glimpse into a time that Earth has long since buried under continents and oceans and life itself. You hold a replica in your hand. It's heavier than expected. Lunar rocks are dense, compacted by eons of micrometeorite bombardment. The moon's surface is constantly peppered by space debris. No atmosphere means no protection. So the outermost layer becomes something called regolith, a fine, dusty blanket of shattered minerals and glass beads. Yes, glass. Tiny fragments formed by the sheer heat of impact events. Some of those impacts were so intense they vaporized parts of the moon's crust, only for it to rain back down as glittering ash. You walk past a sample of that very regolith. It looks like dull gray sand, but under a microscope. It's full of surprises, tiny spherical beads, sharp-edged shards, and even grains older than the moon itself. Some of these minerals predate the solar system, forged in ancient stars before being swept into the dust cloud that became our sun. Talk about ancestral DNA. Now step back, zoom out. The moon has no plate tectonics, no weather, no erosion, which means its surface holds a 4.5 billion year geological scrapbook. By studying lunar rocks, we've traced not only the moon's history, but Earth's early history, which is mostly lost to time. Our planet's oldest rocks are rare and fragmented, but the moon, she remembers everything. Here's a particularly poetic twist. The moon might be holding clues to life's origin, not because it ever hosted life, but because it protected traces of Earth's earliest biochemistry. Some scientists believe that meteorites hitting Earth billions of years ago may have blasted organic molecules into space. Some of those fragments may have landed on the moon, frozen in regolith, perfectly preserved. Yes, the moon might be hiding ancient whispers of Earth's first attempts at life. And we're just getting started. The Apollo missions brought back 382 kilograms of moon rocks. But new missions, like Artemis, plan to dig deeper, explore permanently shadowed craters, and search for water, ice, and untouched material. There are whole regions of the moon we've never sampled, including the far side, the poles, and deeper volcanic plains. Each sample is a data point, a page of a story we didn't even know we needed to read. you pause beside one final exhibit, a moon rock on loan, encased in glass, resting on a black velvet cushion. A small sign invites you to touch the case. So you do. And for a moment you feel it, the chill of ancient time, the echo of planetary violence, the hush of a world with no wind, no water, no breath, but full of history. The moon is more than a nightlight. It's a record keeper, a curator of cosmic memory, a dusty librarian who's been holding on to Earth's lost chapters, waiting for us to ask the right questions. And now that we're finally reading the moon's pages, we're beginning to see our own story more clearly. Not just where we are, but where we came from. And maybe even where we're going. You're floating again, but this time you're not alone. Around you, metal glints in the sun. Dust swirls in low gravity. There are boot prints in places where no atmosphere should let them stay. And above you, Earth hanging in the black sky like a marble of light. Blue, alive, impossibly beautiful. You've arrived at one of the most significant intersections in human history. When we left home, stepped onto the moon, and then looked back. Tonight, you walk with the Apollo astronauts, not as a tourist, not as a science student, but as someone chasing the moon's long arc back toward understanding ourselves. Because in 1969, when humans first touched lunar soil, the moon gave us one final gift: perspective. Let's rewind. It's July 20, 1969. The world is holding its breath. The radio crackles. Houston, Tranquility Base here. The Eagle has landed. And suddenly, the moon is no longer just myth, light, or gravity. It's a place, with dust, with rocks, with two men in white suits bumbling across the surface like careful toddlers in slow motion. You float just above them now, watching Neil Armstrong and Buzz Aldrin deploy their instruments, collect samples, and, of course, plant the flag. But it's not the flag that leaves the deepest mark. It's the photographs. You know the ones. Earthrise. The blue marble. Images taken from lunar orbit and later Apollo missions that showed Earth not as an endless terrain, but as a fragile sphere suspended in darkness. No borders, no politics, just a single shimmering home. Before the moon landing, we looked up. After it, we looked back. And that shift, the emotional and ecological awakening sparked by seeing Earth from afar, is one of the moon's most unexpected gifts. Here's your quirky tidbit of the evening. In 1970, just a year after Apollo 11, the very first Earth Day was held. Coincidence? Maybe. But many believe that seeing our planet from the moon helped spark the modern environmental movement. Suddenly, we weren't just inhabitants, we were stewards. You drift inside the lunar module now. It's cramped. Every surface is covered in switches, wires, Velcro, and tape. There's no bathroom to speak of. The food is bland, the suits are stiff, and the risk astronomical. But the men who flew here say it was worth it, not just for the science or the adventure or the politics, but for the view. Astronaut Edgar Mitchell, who walked on the moon during Apollo 14, described it this way: you develop an instant global consciousness, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. It's called the overview effect, a psychological shift that happens when you see Earth from space. You stop thinking like a citizen of a nation and start thinking like a citizen of the planet. And without the moon, we might never have felt it. Because the moon is the only celestial body we've ever visited. It's just close enough to reach, just alien enough to transform us. We didn't land on Venus. We didn't step onto Mars. We came here to the one rock that's been with us all along, the one that shaped our tides, our time, our myths. And in return, it showed us who we are. You touch down gently now, your boots leaving a perfect imprint in the lunar dust. That dust is older than all of recorded human history, unchanged for billions of years. You scoop a handful, let it fall in slow motion. No wind to scatter it, no rain to wash it away, just the pure stillness of the moon. Nearby, you spot remnants of the Apollo missions, flags, rovers, laser reflectors still used to measure the moon's distance from Earth. Silent monuments to our brief, dusty visit. And maybe the most poetic one, a small memorial plaque placed by Apollo 15, honoring astronauts and cosmonauts who died in pursuit of space. There's also a tiny sculpture left there, a fallen astronaut, arms by its sides, facing Earth. The moon became a memorial, but also a mirror. You look up at Earth again. You're far enough away now that you can cover the planet with your thumb. One small gesture and everything you've ever known, oceans, mountains, every song, every love story, is hidden behind your fingernail. And somehow, that doesn't make it feel smaller. It makes it feel more precious. Here's your historical gem. During Apollo 8, the first crewed mission to orbit the moon, astronaut Bill Anders took the now iconic Earthrise photo. He later said, "We came all this way to explore the moon, and the most important thing we discovered was the Earth." The moon has always pulled at us, with gravity, with beauty, with myth. But in that moment, in those missions, it gave us something even greater: perspective. It let us see ourselves not as rulers of the world, but as passengers. It reminded us that our planet is rare, fragile, stunning, and very much alone. Now you rise from the surface, lifting into the sky like a ghost of the past, watching the bootprints disappear behind you. You'll be back someday, not just with flags and samples, but with labs, habitats, maybe even towns. The Artemis missions are coming. Lunar bases may follow. Humans may once again walk these dusty plains not as visitors, but as neighbors. But even then, we'll still glance over our shoulders. Back at Earth. Back at home. Because no matter how far we go, the moon will always be the first step. The quiet satellite that pulled us skyward and gently turned our gaze inward. You're staring at a blueprint now, not for a house, not for a ship, but for a world. It's spread across a glowing table, projections shimmering in pale blue. Lines arc through atmosphere, calculations snake around craters, and next to it all, a small sphere turns slowly in simulation. It's not Earth, it's not the moon either. It's something new. Tonight, you're standing at the crossroads of terraforming and moons, looking ahead to the future, to the dreams of planetary engineers and space architects who ask, what if we could build the conditions for life somewhere else? And more provocatively, could we build a moon too? You've spent the last 17 sections exploring how Earth's moon made life possible. Tides, time, climate, calendars, stability. The list goes on. But here's the twist. If we ever hope to live permanently on another planet or moon or even a floating station, we'll need to recreate what the moon does for us. And that's going to be complicated. Let's start with Mars. Everyone's favorite fixer-upper. Red, dusty, and cold, but not entirely inhospitable. It has ice. It has carbon dioxide. It has a day only 40 minutes longer than ours. Not bad. But what does it not have? Tides. A stable axial tilt. A large stabilizing moon. Any significant magnetic field. You float now over the Martian surface. Below you, ancient riverbeds wind through rust-colored canyons, silent for eons. The planet once had water, maybe even oceans. But no big moon meant no tidal cycling, no deep mixing of chemistry at the coasts, and no consistent climate to keep things alive. And remember Phobos and Deimos from section 14. They're cute, but they're not helping. Here, where things get sci-fi, but not that sci-fi. Some scientists and futurists have proposed creating artificial moons or orbital mirrors to simulate the moon's most crucial functions. Want tides? Drop an artificial satellite into close orbit with just the right mass to pull on Martian seas. Want climate stability? Add a moon-sized object to slow and steady Mars's wobbly axial tilt. Want more light during Martian night? Build orbital mirrors to reflect sunlight like a giant metal moon. Sounds ambitious, because it is, but so was walking on the real moon. Quirky idea of the evening. In the 1990s, NASA scientists proposed placing a space mirror in orbit to increase light on Earth's surface during nighttime hours, primarily for energy efficiency. It never launched, but it did inspire later concepts for off-world lunar reflectors and planetary stabilizers. Now imagine you're designing an entirely new exoplanet colony, not just visiting, living there. You need to build in rhythm. Literally. People need days and nights, light and dark, sleep cycles, circadian rhythms. We're not just carbon and water, we're timed carbon and water. Without a moon or some artificial cycle to replace it, those rhythms start to fray. Sleep patterns break, hormones get weird, mental health tanks. And let's not even start on trying to plant tomatoes without seasons. So in your blueprint, you now sketch in something crucial: lunar simulation systems. Maybe it's a rotating station that mimics lunar phases through lighting. Maybe it's a small clock moon that orbits your new world and tells time the old-fashioned way. Maybe it's just a data system that mimics the moon's rhythm digitally, syncing sleep and farming and tide generators through precise algorithms. Historians, or rather, future historians, will argue whether humanity's survival off Earth will depend more on technology or on our ability to mimic nature. But smart money says it'll be both. Now let's swing back to Earth for a second. Because even here, scientists are experimenting with tidal energy, harnessing the moon's power not just as a poetic metaphor, but as literal electricity. Massive underwater turbines are placed in coastal regions where the moon's pull moves millions of gallons of seawater in and out twice a day. It's reliable, renewable, and silently powered by our nearest celestial neighbor. So when we talk about the moon shaping life, we're not just talking past tense. We're still using it, still learning from it, still trying to copy its homework. And here's your fun, spacey tidbit. Saturn's moon Enceladus has active geysers, huge jets of water vapor and ice that shoot into space. What causes it? Tidal flexing. Saturn's gravitational pull squeezes the moon's core, generating heat. Some scientists think that if we ever colonize Enceladus, ambitious, yes, we might build with that tidal power in mind. A moon-like mechanism, once again shaping the conditions for life. Now you stand in the observation deck of your hypothetical future colony. Maybe it's on Mars, maybe it's on a space station, maybe it's on a moon of another star entirely. You look out, and there, rising over the horizon, is your artificial moon, a glimmering sphere orbiting on schedule. It controls light. It stabilizes tilt. It keeps time. And suddenly, it feels like home. Because maybe that's what the moon has been all along. Not just a rock, not just a satellite, but a symbol of rhythm, of trust, of return. New moon to full moon. High tide to low. Plant to harvest. Awake to sleep. And in building a new world, we'll carry that rhythm with us. Whether in glass or steel or programmed sky cycles, we'll need to bring a little moon with us wherever we go. Because deep down we are creatures of cycles, of repetition, of return. And the moon taught us how to listen for the beat. You stand in a quiet field, the grass around your ankles swaying slightly in the night breeze. The air is warm, still, full of the hush that only happens in the deep hours between midnight and dawn. Above you, the moon is as familiar as ever, still silvery, still bright, still just hanging there. But tonight, you know something you didn't before. It's leaving. Not quickly, not dramatically. No explosion. No goodbye note carved into the regolith. Just a slow drift, about 3.8 centimeters a year. Roughly the rate at which your fingernails grow. But make no mistake, the moon is pulling away, and eventually Earth will feel it. You lie down now, spine against the ground, and stare upward into the great dome of stars. It's a nice view, but not quite the one early Earth had. Remember, the moon used to loom 15 times larger in the sky. It was huge, intense, beautiful in a way that probably scared the first organisms lucky enough to develop eyes. Over the last 4.5 billion years, that distance has stretched, and Earth's rotation has slowed in kind. The two effects are linked. Each time the moon pulls at Earth's tides, it steals a tiny bit of our planet's rotational energy, slowing our spin and using that momentum to push itself outward. It's a gravitational trade-off, a planetary whisper. 1 inch further, 1 millisecond longer. And it's still happening. Right now, the moon is about 384,400 kilometers away. It used to be just 22,000 kilometers out. That's a big difference. And in another 600 million years or so, it'll be far enough that total solar eclipses will be a thing of the past. The moon won't quite cover the sun anymore. Just a slightly too small coin trying to blot out a flame. It'll still be beautiful, but not the same. Historians, geologists and astrophysicists still argue about the long-term consequences of this drift. Will Earth eventually become completely tidally locked with the moon? That is, will one side of the Earth permanently face the moon, just like the moon always faces us? Possibly. It's called mutual tidal locking, and it happens when the spin and orbit of two bodies synchronize completely. The moon's already there. Earth's just taking its sweet time. If it happens, Earth days would eventually stretch to 47 current hours. One rotation every 2 lunar orbits. But this process will take billions of years, longer than the sun has left in its main sequence. So chances are, the sun will balloon into a red giant and roast the inner planets before we get to see Earth slow dance into permanent lockstep with the moon. A cheerful, right? But before we get vaporized in a stellar retirement party, Let's focus on what the moon's slow departure means for life now and in the future. For one, tides will weaken. The moon's gravitational influence will fade as it drifts. Less tidal energy means less ocean mixing, fewer nutrient cycles, and a gradual change in marine ecosystems. Coastal regions will shift. Intertidal zones, those evolution-friendly tide pools we visited back in Section 11, will become more static. The ocean's pulse will slow. And so will Earth's rotation. Right now, each day is about 24 hours, but it didn't start that way. Back when the moon was closer, Earth spun much faster. Days were only about 6 hours long. As the moon moves away, our days stretch ever so slightly longer. Eventually, they'll grow so long that life itself may need to adapt to an entirely new rhythm. Imagine creatures evolving to wake for 30-hour days, or crops that bloom only every 2 rotations. Human society, our tech, our culture, we'd need to recalibrate everything. Here's your quirky tidbit. Scientists have already confirmed the moon's drift using retroreflectors placed on the lunar surface by Apollo astronauts. We bounce lasers off them and measure the return time down to the millimeter. So yes, we're watching our cosmic companion slip away in real time. And while that sounds sad, like the end of a very long, very loyal friendship, it's not all doom and gloom. The moon may be leaving, but it's not abandoning us. Its influence will echo for eons. Tidal basins, fossil rhythms, coral rings, ancient calendars, all of it traces back to the moon's presence. Even in absence, it'll shape Earth. You stand now at the edge of a lake. The moon's reflection shimmers in the surface, wobbled slightly by a ripple of wind. The water is still, but deep beneath it, tidal forces continue their ancient cycle, just a little weaker than yesterday, just a little slower. Some scientists think the moon's drift is part of a grand cosmic pattern, that over billions of years, moons form, orbit, drift, and eventually break free or disintegrate. The moon could, in a distant future, reach a point where Earth's gravity can't hold it, and then either become a rogue satellite or get torn apart into a ring system. Yep, Earth could end up with Saturn-style rings. Don't get too excited. It wouldn't happen for billions of years. And they wouldn't sparkle. It'd be dust, debris, pulverized pieces of our once glorious moon. But for now, it's still here. Still rising, still pulling, still writing invisible lines into the oceans and the air. And maybe that's the comfort. Yes, the moon is drifting away. Yes, someday it'll be different. But tonight it's still yours. Still watching over the tides. Still glowing through your curtains. Still holding the beat of your blue planet's ancient lullaby. So lie back, close your eyes, and whisper goodbye in millimeters. You're back where you began, lying in the soft dark, eyes half open, the moon overhead, still following you like it always has. But something's different tonight. You're not just looking at the moon, you're seeing it. Not as scenery, not as superstition, not as the thing that makes wolves howl in cartoons, but as a quiet architect of the possible, a shaper of you. Because now, after all this drifting, digging, and dreamy science, you know the truth. The moon didn't just light up your nights. It made you possible. It's a heavy thought, but not in a scary way. More like the comforting weight of a warm blanket. The moon's story is tied to yours and always has been. From molten chaos to silver glow, from dust to DNA, from tidal foam to Fibonacci spirals. Let's rewind one last time. Without that fateful collision with Theia, there is no moon. Without the moon, Earth doesn't slow its spin. Without the slowdown, you get 6-hour days. No stable axis tilt, no reliable seasons. No strong tides, no tidal mixing. No intertidal zones, no easy transition from sea to land. No gentle lunar glow, no guidance in the dark, no rhythm to watch, no way to mark time. No full moon restlessness, no ocean migrations, no moon-shaped mythologies etched into bone and belief. And that means no agriculture calendars, no night journeys across ancient oceans, no neatly repeating lunar months tied to our biology, no synchronized coral spawning, no poetic eclipses, no Earthrise photo, no overview effect, no Neil Armstrong's boot print, and probably no you. Not the you sitting here now, under the low glow of a desk lamp or phone screen, nodding off while the moon hangs somewhere just beyond your window. Of course, historians and scientists still debate whether life could have evolved differently. Maybe through solar tides, maybe on a planet with a different orbit, or a twin moon system, or something else entirely. But when you look at Earth's long history, the evidence is as soft as it is solid. The moon is why this planet breathes in rhythm. You roll onto your side now, cozy in the covers or curled up on the couch, as the moonlight from outside turns everything just a little silver. It's still rising, still pulling, still packing above you in its steady 29.5-day loop, waxing, waning, whispering. You may not be watching, but it's doing its thing anyway, unbothered, unbending, unrelenting. Not flashy, not loud, just there. And maybe that's the most magical thing about the moon. It never needed your belief. It never demanded a temple or a telescope. It didn't ask for poems or rituals or songs. But it got them anyway, because we felt it long before we understood it. We felt the pull, the timing, the return. Every newborn gaze lifted to the moon and found comfort. Every sailor charted a course and thanked it. Every farmer looked up and nodded. Every sleepless soul stared out a window and whispered, "What now?" And the moon answered, maybe not in words, but in light, in motion, in silence. Now you let your eyes close fully. You know the moon will still be there when you wake up, just a little further, just a little dimmer, but still yours. Because whether it's stirring plankton or sinking coral, helping plants grow or turning fish into navigators, shaping brains, dreams, cultures, calendars, or coastlines, it's always been doing one thing: keeping Earth alive, keeping Earth steady, keeping Earth ready. You live on a planet with a moon, and that changes everything.